Hello and welcome to our lesson on causes of river flooding. Our three key takeaways today are to describe the causes of river flooding, to explain how they can create a flood event, and hopefully link them to a storm hydrograph as well, and then to categorize them between natural and man-made causes. So we'll try and do all of those different elements today. So first of all, our key questions that we need to address are: what factors lead to flooding? There are 5 on the screen there, so we'll just highlight those as examples that we can refer to, and consider whether they are natural or man-made. So first of all, think about what each picture might resemble. Give yourself a little bit of time just to look through this. So the first image, okay, this shows a flooded road, okay, and it's that idea of tarmacked road. So I'll link this to an urban surface, okay. So this is something, these urban surfaces are basically impermeable materials, which means they don't let water through. Okay, so they won't let any water through, which means it will collect. Now, the bigger a town is, the more of that material there'll be. So the more of that water collects and it doesn't store in the ground. So it's going to rush into that river and create that flood event. If we look over to the other side, so over here we can see steep terrain, okay? So mountains, okay? And this, any rain that falls in this area will rush down that terrain into that river, which is right at the bottom. Okay, so less water is absorbing or infiltrating into soil, so it will run down much faster into that river, so increasing the flood risk of that river. If we go to the middle image, we've got 2 different pictures here. Okay, we link back to one of our previous lessons. So these are both drainage basins, but one you can see has more streams and rivers than the other. Okay, so this is drainage basin density, and the higher the density, the more flood risk. Because the more water will be drained through the rivers at a quicker rate. And then we're looking down here. So this is based around the rock type or geology. Okay, and this actually looks like granite. So rock type, so I'll just put down granite, which has the property of being impermeable, which means water can't absorb into it, therefore it runs on the surface and it goes straight into the rivers. So that can trigger a flood event if the whole area is made of this impermeable rock type, very similar to that urban surface. And then the last one. This looks like trees being cut down, so I'll put down the term deforestation. Okay, and this basically means that less water will be intercepted by the trees. So that basically means the water is not being caught by the trees, but it will fall directly onto the ground and go at a quicker rate into the river. Okay, so that can trigger another flood event because the water is traveling faster. So whether they are natural or man-made, okay, so we'll do natural in green and man-made in red. So natural has got to be our landscape. So steep terrain, we don't change that, but that's naturally what an area is given. Same with our drainage basins. We can't change that. The rivers are naturally created. Some will have more than others, okay? And we can't change our rock types. Some will be permeable, some will be impermeable. So these are all natural characteristics. So the man-made ones are our urban surfaces. These are impermeable materials that we can create, okay, or we do create with our urban areas. And deforestation, this is what we do, okay, as people. We are in control of it, so therefore we are causing that flood risk, okay. So what we'll try and do now is apply this to our storm hydrograph. So what we'll do, we'll clear these off. We'll link to our storm hydrograph. So we'll just pick out a few key bits. So this is our rainfall event. Those blue bars represent rainfall, okay. We can see time at the bottom, which shows how the river has changed. So these lines, I will draw black. So this line here and this line here, that represents the river's discharge, so how much water is flowing in that river. It's measured in cubics or meters cubed per second. Okay, so it's the volume, speed of water at a certain point. Okay, so we've got one river, so this is our highest rainfall event there, and this is our highest river peak there, and our highest discharge or river discharge peak there. Okay, now just by looking at this, talking about this term lag time, which I'll just highlight. Okay, and we'll just highlight that there. So one has a short lag time, one has a longer lag time. You can also see the peak discharges are different. So what we mean by lag time, it's the time it takes for the rainfall to hit the river. So one, it's going to be really short. So we've got a short lag time there, and one has got a much longer lag time. It's taken a lot longer for that river to hit its peak, for that rainfall to get into that river. So therefore we need to think, right, what is going to lead to these things? So first of all, if water can't be stored in the ground, okay, and let's use purple to represent this. Actually, yeah, let's use purple. So impermeable rock will lead to a steep or a shorter lag time. Steep terrain will lead to a shorter lag time. Impermeable surfaces will lead to a shorter lag time. Deforestation will lead to a shorter lag time. And I'll focus on B here. Higher drainage density will lead to a shorter lag time. Okay. So this basically means all of these things will lead to a higher river discharge, so more water in the river, and that discharge, that high peak discharge, will be achieved at a much shorter time. So that means that flood risk is going to be higher. So I'll just put with A, there'll be a higher flood risk. Okay, whereas B, we're going to find pretty much the opposite happening. So what we'll do is we'll just clear this and we'll just identify it on a little bit clearer background. Okay, so if we go to river A, okay, which is the one on the left, so this has the short lag time, so the time between the peak rainfall and peak discharge. So short lag time, and it's got a high discharge. And the reason for that is because water, the rainfall, rushing into the river instead of absorbing into the ground. And the reason we have that, as we mentioned before, so the causes were permeable rock type like granite. We've got urban surfaces, tarmac, concrete that won't let water in. Deforestation or less trees, which means the water will travel faster into the river. We might have steep terrain, which rushes the water down according to gravity, or rushes down into the river at a faster rate and infiltrates less into the soil. And then our final cause that will lead to that steep, flashy discharge line is our drainage density. So just clear that up. Higher drainage density. So these are all causes, okay? So these are all causes of things that might lead to flood risk. So if we just quickly find the alternative, so River B has got a longer lag time. That means it takes longer for the rainfall to get into the river, or lower peak discharge. Okay? So therefore, rainfall is taking longer to reach the river. So more will be absorbing to the ground. Okay, so we're basically looking at the opposite happening here. So the causes of this, so the opposite of the flood, the factors that can lead to a flood event, you might find more permeable rock that allows water to soak into it. You might find there is less urban areas. Okay? So we might be in the more rural countryside. There might be more trees, vegetation. You'd assume so because we're in the countryside now. Okay? Or maybe more trees are being planted. Maybe the terrain will be gently sloping. So water isn't rushing down that steep terrain. Maybe there'll be a lower drainage density. So if we have a little look, just a reminder, so these are our two polar opposites. So we've got River B following here, that's pretty much more natural. We've got our River A, which looks like it's more at risk of flooding due to man-made causes. So let's just highlight these again. So urban surfaces and deforestation. These are man-made, man-induced ones. Okay. In terms of the green, impermeable rock type is natural. Steep terrain and high drainage density are natural. Okay. So in terms of this, urban surfaces and deforestation have led to a significant change there in that lag time. If we look at all these, permeable rock is a natural factor. Less urban areas, so this is basically being more natural, more in the countryside. That is what the natural surroundings should be like. Okay, more trees or vegetation, or that's just being in the countryside. Gently sloping land and drainage density, these are all natural factors, so it tends to be that lower lag time is pretty much going to be more a natural environment, but also one that has these kind of characteristics. One thing to bear in mind, that man can also cause this lower flood risk through, instead of deforestation, afforestation. They can counteract that as well. Okay, but we'll just put that in brackets. Otherwise, a more natural environment with these characteristics is less inclined to flood. So hopefully that clears up the factors that can affect flood risk in an area. So what we'll do, we'll just summarize before we finish. So first of all, what causes river flooding? So steep terrain, impermeable rock, urban surfaces, deforestation, and high density drainage systems. These aren't only factors. There are many, many more, but these are some of the key ones that we can look at. And then we want to explain them. So steep terrain means water has less time to infiltrate into the ground because it's rushing downhill. Impermeable rock means less water is stored in the ground. Urban surfaces acts in the same way as impermeable rock. It doesn't allow water to soak into the ground. Less trees through deforestation reduces the amount that they can intercept before reaching the ground, which slows the rate of water entering the ground and the river. And high drainage basins, drainage systems, high density of them, have more rivers to drain rainfall. So the more rivers that there are, the faster that water is going to be moving into the rivers further downstream. And then we've divided them between natural and man-made causes. So natural were the terrain, the impermeable rock, and the drainage basin systems. The man-made factors were deforestation and urban surfaces. So hopefully that's helped you with the causes of flooding. Thank you very much for listening. Have a good day.